This is the Math 7 review video, and we are going to cover rational numbers. So this video will cover how to change fractions into decimals, how to change decimals back into fractions, and then all four operations with both positive and negative fractions. Let's go ahead and get started. Our first problem says we're going to turn our fraction into a decimal. So when we're in this process, the best thing to look for is to see, can we change our denominator into a multiple of 10, so like 10 or 100. Here, it's not as easy. So if we get to that point where we really can't think of a number we can multiply to get to 10 or 100, we would actually just turn this into a division problem. So we're going to do 5 divided by 8. So we know 5/8 is smaller than 1. So when we're dividing, we're expecting a decimal. So 8 can't go into 5. We're going to add a decimal, bring that straight up, add a 0. So 8, we have to decide how many times 8 can go into 50. And here 8 can go into 5 6 times, or 50, excuse me. So 6 times 8 gives us 48. 2 is our remainder, so we're going to add a 0 to drop that down to continue our division. So 8 times 2 is 16. We've got 4 left over, so we're going to keep this adding zeros, dropping it down. 8 goes into 40 5 times, and we have no remainder. So 5/8 as a decimal is 625 thousandths. So we're going to move on now. We've got decimals into fractions. So with this, the way you say your decimal, so wherever that decimal ends, whatever place value that is, that's going to really tell you what your denominator is on your fraction. So we've got 3 wholes. We're going to put 3 as our whole. And then here we've got 52 hundredths. So we're actually going to put 52 over 100. So at this point, we either finished our problem or we need to see if we can simplify. So 52 hundredths can actually be simplified. We can divide these at least by 2. We can try that first. So 52 divided by 2 is going to give us 26 over 50. Again, that can actually be simplified by 2 again. And we've got 13 over 25. That can't be simplified any farther. So our final answer is 3 13/25. So moving right along, we're going to order these numbers from least to greatest. So in this case, I like to deal with decimals. So I'm going to take my fractions and turn them into decimals so I can figure out which place I put them in our list. So I'm going to leave 1.6 alone. I'm going to leave negative 0.5 alone. This negative 2/3, if I needed to do my division, it's going to be negative 6/10 repeating. 3 halves, excuse me, is 1.5. And then negative 5 halves is negative 2.5. So with this, I'm going to order them from least to greatest in original form. So I'm going to look at my negatives first. My negative 5 halves is the smallest. So cross that out. Then I've got negative 6/10, so negative 2/3. Then I've got negative 5/10. I've got 3 halves. And I've got 1.6. And that's from least to greatest. So I turn them all into the same type of number so I could compare them a little easier. It's also really good to look at your negatives first and see if you can order those differently or a little bit easier. Sometimes you don't have to change all of them into fractions or all of them into decimals depending. So just keep that in mind as you're going through these types of problems. We're going to move right into adding rational numbers. So when we're both adding and subtracting these fractions, these positive and negative fractions, we need to make sure we have a common denominator. So for our first problem here, I've got negative 3/5 plus negative 4/15. So my common denominator isn't there yet. I know it should be 15. So I'm going to multiply my first fraction by 3. So I'm going to have negative 9/15 plus a negative 4/15. Now this is where our integer rules come into play. So if I'm looking at my numerators, I have negative 9 plus negative 4. So when I have the same sign when I'm adding, I'm going to add the values, keep the sign. So I've got negative 13, and then my denominator is already 15. So I have negative 13/15 as my answer there. The second problem is pretty similar. We still need a common denominator. The only difference here is that we've got this whole number that we have to deal with. So we're going to turn that into an improper fraction. So I'm going to drop down my negative 7/2 since I'm not doing anything with that yet. And I've got 3 2/3. So 3 times 3 is 9, plus 2 is 11 over 3. Now I can get a common denominator of 6. So I'm going to multiply my first fraction by 3, my second fraction by 2. So I have negative 21 over 6 plus 22 over 6. Again, I'm just looking at those denominator or those numerators. So negative 21 plus 22. Here, different signs, so they're canceling each other out, and I've got only one positive left. So my answer here should be a positive 1/6. Moving on to subtracting. Again, we still need that common denominator, but with subtracting, we want to keep, change here. Not to be confused with keep, change, flip, which we'll see in a little bit, but we want to keep, change this. You can do that first, or if you need to turn things into improper fractions, you can do it second. It really isn't going to matter here. So I'm actually going to do keep, change first here. So I'm going to keep negative 1/3 the same. I'm going to change this subtraction into addition, and I'm going to change this sign of negative 9/4 into positive. I'm just going to write it as 9/4. Now we've turned this into an addition problem, and just like with addition, we need a common denominator. So we're going to get our denominator of 12. So our first fraction is going to be multiplied by 4. Our second fraction is going to be multiplied by 3. So I've got negative 4/12 plus 27/12. Once we have that common denominator, now we're just worried about our numerators. Negative 4 plus 27. Sometimes it helps to rewrite that numerator problem to the side just so you can focus on the integer part of it. So here we get a positive 23 over 12. Now that's improper. So we need to see how many groups of 12 can we pull out of 23. We can only take 1, and we've got 11 left over. So we've got 1 and 11/12. For our second problem, I'm going to turn these both into improper fractions first. Now there are a few ways we can do this. I know people were doing our problems in a couple different ways. I'm going to stick with this method since we've been practicing it the most. So I've got 2 times 3, which is 6, plus 1 is 7, so it's negative 7 over 2, minus 6 times 1 is 6, plus 5 is 11 over 6. So now we've got all of those mixed numbers taken care of. I'm going to get myself a common denominator first. So I just have to change this first fraction and get a denominator of 6. So I'm going to multiply by 3. So I have negative 21 over 6 minus 11 over 6. Now this is where keep, change is really helpful, because if we look at our numerators, negative 21 minus 11, that's a really common subtraction integer problem that students tend to miss. So I'm going to keep, change this. I'm going to write keep, change. I've got negative 21 staying the same. Change this to addition, and then change this positive 11/6 to a negative 11/6. So now I'm just adding my numerators together, negative 21 plus negative 11, and I get negative 32 over 6. Now again, this is an improper fraction, so I have to see how many times 6 can go into 32. So I know that 6 can go into 32 a total of 5 times, and then I've got 2 left over, 5 and 2/6. It is negative, so we need that negative sign. But I can actually simplify that 2/6. So it's going to be negative 5 and 1/3. On to multiplying. With multiplying, the good part about this is we do not need a common denominator. The only thing we need to worry about is if, like on this second problem, if we've got mixed numbers, they need to be improper fractions. But if we start with our first one, since we don't need to do anything with mixed numbers, we look to see if we can cross cancel. That's the best thing we can do right off the bat. We don't have to do with larger numbers. I can cross cancel 2 and 6. And I get 1 and 3 if I divide them both by 2. 15 and 25 can both be divided by 5. So 15 becomes a 3, 25 becomes a 5. Now I've got a negative times a negative, and that is a positive answer. If we go back to our integer rules there. So then once we've done all of our cross canceling, we're going to multiply straight across, and we get 5 over 9, and we know it's positive, so our answer is 5/9. Now our second one, We've got a positive times a negative, so we've got different signs. The answer is going to be a negative value, and we have to deal with some mixed numbers. So we're going to turn these into improper fractions. So 3 times 1 is 3, plus 2 is 5, so we've got 5/3 multiplied by a negative 29 over 10. So here I can cross cancel 5 and 10. 5 becomes a 1, 10 becomes a 2. And we can't do anything with 3 and 29, so we actually just have to multiply straight across there. So we get 1 times 29 is 29. 3 times 2 is 6. So now we need to see how many times can 6 go into 29. So we know we can get a total of 4 groups of 6. That's 24. And then we have 5 left over, so 5/6. We said it was negative, so our answer has to be a negative 4 and 5/6. We've got 2 more problems, dividing rational numbers. Here's where we do keep, change, flip. So what we need to deal with first, if there's any mixed numbers, we have to turn them into improper fractions. And then we keep, change, flip, look to cross cancel, and multiply. So our first one, there's no mixed numbers, so we're just going to do our keep, change, flip. We've got negative 1/9 multiplied by negative 30 over 13. Now again, I've got a negative divided by a negative. That is a positive value based on our integer rules. So then we're going to look to see, can we do any cross canceling? With 1 and 13, no, but with 9 and 30, we can. We can actually divide them both by 3. So 9 becomes a 3, 30 becomes a 10. So when we multiply straight across, we get 10 over 39, and it is positive. Our last problem says we've got 2 mixed numbers, negative 2 and 4/5, and 10 and 2/3. So we've got a positive divided by a negative. This is going to be a negative answer at the end. We're going to turn these both into these mixed numbers into improper fractions. So our negative 2 and 4/5, we've got 10, negative 14/5. I'm going to keep this division until I've turned these into improper fractions. So 3 times 10 is 30, plus 2 is 32 over 3. So now I'm going to do my keep, change, flip. Negative 14/5 multiplied by 3 over 32. Now 5 and 3, I can't do any cross canceling there, but 14 and 32 I can. They are both even, so I know I can divide them both by 2. My 14 becomes a 7, and my 32 becomes a 16. So this one's going to have a little bit bigger numbers, which is no big deal. 7 times 3 is 21, and then 5 times 16 is 80. So we've got 21 over 80. Because we can't do any simplifying, that is our final answer. We need to make sure we have our negative sign right there. So our answer is negative 21 over 80. So feel free to rewatch any of the sections of this video. Make sure you review your notes, review your integer rules will be very helpful. Look over any graded homework, and good luck studying.